Hello everyone, welcome back to our Spring Boot series. Today I'm returning to the JDBC template series and I will be talking about complex queries, meaning what if we have a query that it's a join with multiple tables and we need those values to be put in different entities, something that we didn't address yet in our previous videos when I talk a lot about JDBC template, but always with a specific entity in mind. So let's see how can we do it in JDBC template. So before that, let's recap quite fast what is JDBC template and what are the advantages. Again, I have provided already videos about this JDBC template. You can check them on my channel, even with some code that you can find in my YouTube channel post, in the posts area where you can see the address of the GitHub. And usually for each one of the videos that I create, I usually create a different commit that starts with the, let's say, the episode, let's say part 30, part 31, and things like that. So you can follow the code that I use, that I usually use here at the end of the video. So I provide a set of, as you know, slides, but if it's your first time here, and then I will provide a final example so you can see in practice how to implement, and maybe you can take the code and change yourself on your machine and explore the code differently. So again, what is JDBC template? Part of the Spring JDBC model and simplifies SQL query execution result set extraction, meaning at the end of the day, you need to perform queries and you need to map to entities that you have, Java class. You can just do something like this. You put this on your bin, private JDBC template, you auto hire like this, or maybe in a constructor injection, and by default, you have access to database, a connection will be open for you, even a data source will be injected here, which will be the default database. Of course, you can customize this using configuration bins, and where you explicitly create yourself a JDBC template or a data source. That's possible. Also, I created a video explaining that, but if you want to go simpler, this line should be enough. So one advantage of the JDBC template, it can handle for you the connection, the prepare statement, the result set, everything. It's out of the box. You don't have to take care of this. It will be taken care for you. So behind the scenes, JDBC template uses a prepare statement, which allows, for instance, a very elegant way to handle parameters in queries, and automatically manage for you open and closing connections, the preparing of the statements, and mapping results using, for instance, RowMapper or ResultSetExtractor. But there are others like a BeanPropertyRowMapper that can set the values for you, and I will see you in a moment. But however, the SQL queries must be written manually. It will be on your side to write the query, which is quite different if you use technology like object relational mapping, like Hibernate, that can write for you. But I think Hibernate has a different purpose, a different scope of the SQL. So it's not that the Hibernate is the next step of a JDBC template, it's just a different technology. Okay. Mapping simple results, you can use something like the BeanPropertyRowMapper. Usually this is a way to call the JDBC template. You write your query, then you have several methods that you can use. You have query for object, and things like that. You can explore them in my previous videos, or even in the Spring Boot documentation. And then you provide the query. When you have parameters, you can provide also parameters. And then you provide here a RowMapper. And there are several of them that you can put here. You can put a BeanPropertyRowMapper. This is a quite simple one, because if you provide here a class and the fields of the class match the names that you put here on the select, you just write this line of code, and the behind the scenes JDBC template will instantiate the class. We use reflection to set the values that it found here for each row, for each one of the entities, and will return to you a list of users. Everything out of the box. I think it's quite great to do this. You don't have to take care about the prepare statement, the connections, the result set, nothing, unless you need some customization on your side. But for that, we'll use a different object here on this parameter. This is I think it's great in some use cases. I think it's the best technology for this kind of things. When you have a one-to-one, meaning the results of your select match completely one entity that you have on your side. Now imagine that you want complex joins. You have two different tables here, orders and customers. The first thing that I can say about this is that Spring Boot doesn't care about the tables. It doesn't understand tables. Spring Boot was not develop to understand SQL. It just understands the result, which is the result set, which is the values that you can see here. And from the point of view of the JDBC template, this is as one entity or multiple entities, it will be on your side. What I'm saying is that JDBC template doesn't have a special mechanism to handle multiple entities. It just understands one entity, and you do whatever you want. When the entity it's not enough, you have to create your own entities and you map yourself the values. And for that, you can use the popular RowMapper on JDBC template, where you use this RowMapper, because there are others like this one. But in this case, we want to customize our entities. And in this case, I want to create a customer first with the customer ID and the name. And then I'm creating the order and I'm putting the customer inside the order. But it will be on my side to do this development. The only thing that we have here out of the box that we don't care, it's to open the connection. The free, let's say, functionality given by the JDBC template, which is it will call this code for each one of the rows that is returned by the select, and then we can return the entity that you want. In this case, we are returning an order, maybe, and probably we are returning a list of orders, but it will be on our side to build this order. That's one way to do it. If you want, you can say, but can I create one entity with all these attributes? Yeah, you can. If for instance, is for, and you can follow something like this. Now you have a challenge, because this is your business classes, your entities in your application. And for that, you have to create, if you want to follow this approach, you have to create a specific entity for that. Maybe something called order with customer details. And that's okay if you are using that entity to return JSON, to send this, to use this information as a return to a request API. Maybe you want to generate a file. Maybe you take this information to do some calculation. In those cases, I don't see any problem to create an additional entity that collects all this information as if it was one entity, because the purpose of the query is not to manage your business, but to use information from your business to an external purpose. It's not that it will be important what is a customer or the order and the relation between them. You are just interested in the values, maybe for reporting, maybe for some charts. And in that case, I think it's okay to create a different bin. I even create this bin sometimes and put in a different package to make sure that their purpose it's different than the regular business entity bins like customer and order. Okay, and that in that case you can use something like the BeanPropertyRowMapper. That's my opinion on this. Now imagine that that you need to get customers and orders, multiple customers, and for each customer there is a set of orders. The first thing that sometimes people think is that, okay, I will take the list of the customers that I want and I will do a query to get the orders where I will filter the orders by this customer ID and I will create my result. It seems a very good structured approach, but it's really bad from the resource point of view, because you will perform as many queries to the database external system as many customers you have. And you can do it just with one query. You can just query everything, something like this, a select with a join, and then we use a map to do that grouping, meaning that you create a map on the key will be the ID of the customer, and then you have here the customer class, which inside contains, it will be something like this. You have the customer, where inside you have the orders. Okay, and now what you do is that you ask to JDBC template to execute this query, and for each row, and this is another way to capture the row, you can just get the ID of the customer, create the customer, put on the map, and you can make use of the great compute if absent. Compute if absent, it's a great addition from Java, because it allows you to say, okay, get me the customer with a specific ID, but if it doesn't exist, I will provide you a value to put there and then return me this value. So you can do in one line something that probably will need you 3 or 4 lines in your code. And which means that you have this customer, which for sure will exist on the map here. And then after you get this customer or build this customer and put on the map and return it again, you start to add the orders to the customer. Remember, this is the orders here inside the customer, you start to add the orders. And you do this for all of them. So every time there is a different customer, you will get from the map, you get this instance and you put inside the order that you found. So you create this 1 to n relation in the map. And then what you want to return a list of the customers, and you can do something like this. New array list, and you put the map, which is this one, values, and you have all of them. So you need one query, and you put the effort of the CPU on the Java side, rather than doing multiple queries, and then you have effort from the CPU and even from the network, which is always slower, every time slower than using just the CPU. Okay, that's the approach that should be used when we are doing complex queries on the JDBC template. And it is proposed to use the LinkedHashMap to duplicate parent. What it is, those LinkedHashMap, and if you read more about it, it will maintain the order. If you have some kind of order of the results that you are receiving here, the values that are on this map will maintain the order because it's a linked list. It doesn't force you in memory to be in a straight order. The linked list, it's inside its pointers. I think it's a good thing if you don't understand what is a linked list. In this case, a LinkedHashMap, but the theory of the linked, it's the same. You have pointers between objects, which is make it really simple to put things in the middle, to remove them without breaking nothing, without let's say, to reorder the elements physically in memory. They always be on the same place. You just put and take things from the list quite easily. So read about it if you don't understand, or if you don't know about it, you read about linked. So that's again, so anti-patterns to avoid: mapping joins directly to next set pages, BeanPropertyRowMapper. It's a anti-pattern because you are creating a bean that it's not related to your business, unless, and as I explained it earlier, you have a purpose for that bean. Again, what I'm saying here is that it's better to use something like this, customer, like this, and have order, or maybe like this one, customer and order. But if it was me, and these results will be to export my file or to a JSON as a response to a request, I will not mind to create a specific bean called, let's say, order with customers details, and then use it to take this information from database and export it, because I will not be doing transactions and CRUD operations on it. So it's not about the business structure or the business management. It will be about the data that I'm exporting and importing. And in that case, I think I don't see this as an anti-pattern, but maybe even a good practice to make sure that it will be faster and really easy to understand. And I could use BeanPropertyRowMapper, and it's better to write something like this with just one line than to do something like this. Of course, if I need to map and extract things, that will not be the case. But again, it depends on the purpose. If you just imagine you had to export to CSV, so you just want a dump from this information. So there's no reason to create a map and structure this or unstructured later. It's quite strange. Okay, so take always these anti-patterns as guidelines. Of course, there are exceptions. Don't take them as a kind of a religious thing. Okay, this is the way to do it. Okay, like the movie from Star Wars, this is the way. Okay, no, not this. This is the only way. Okay, assuming one-to-one mapping to 1-2+ query here. Yeah, meaning that try to do a query like this one. Okay, don't try to do multiple queries like 1 + n. This will avoid the n+1 problem. The n+1 problem, that's one that I stated before. I didn't give it the name, but there is a special name for this, which is I have an entity, and an entity, for instance, need orders. Let's say a customer has orders. So sometimes people do the query for the customer, and then they do another query to get the orders. Now just take all of them in one time and then create a map or extract or remove what is duplicated. It will be simpler in Java. There are a lot of ways to do it. You can even use Java streams to make this for you. So there is no reason to do multiple queries, and that will increase the consumption of the resource. And then overusing inline SQL logic. Sometimes we, like for instance, JSON in columns, sometimes you put on the entity and there is a temptation. Sometimes this word is tricky to say. where you put the annotations about JSON, SQL, Hibernate, and a lot of annotations on the columns, and it starts to be crazy. Just create multiple entities for that. Have special ones to the database for SQL, have others for JSON, unless they are real simple ones. But if they are not, if they require a lot of customization, transient, ignore fields and things like that, maybe it's better to have more than one and create a map between them. Because probably if you have a lot of exceptions, maybe you are receiving 10 attributes, but you want just to export 4, okay, then will be very tricky configuration. It will be very difficult to handle. Best practice and tips: use aliases. So make sure that the columns here, for instance, they follow the same name. Because if you see here, you have this ID here, but you have also the ID for the order. So there can be a lot of conflicts. So the as, let's say, make everything's uniform. So you say that it's customer ID. Let's say here the name, it's not necessary because it's only one name, but if you want, sometimes people like to put as in everything, so to make everything uniform. But if you are using that, use that for all queries, share with your team, maybe on a daily meeting or in a planning, and create a document to say, okay, if you are querying customers, always use these names. So it will be simple if I use the annotations to get the information from the queries. Okay, always use LinkedHashMap because it preserves the insertion order when deduplicating. Use RowMapper for simple one-one and the ResultSetExtractor or another mechanism to one-to-one. The ResultSetExtractor meaning that, okay, it will give me the full result set. It's a different approach, but it works also. Okay, it's what I'm talking about, and you can see on my previous video where I explained the multiple RowMappers that you have. For instance, here we are receiving this result set, but it's a callback. You can see there is no return here. Okay, so mean that we are receiving, but in this case, this code will be executed per row. But Spring Boot also supports on this template to return to you the full result set, and you can do whatever you want with it. So it will not be per row, but you receive all of it, and you can do whatever you want with the result set. That's another way to do it. Favor batch queries over per objects to avoid the n+1 again query problem. So batch query means that you do a query that returns all the information that you need, and then on the Java side you group, you filter, you remove duplicates and things like that, and create the results at the end because it will be faster. Okay, use constructor-based mapping for immutability. Immutability, it will be a concept that I will for sure create a video about it, but it's always a good thing. For instance, Java provides records if you want to go full immutability on data. When to switch tools, JdbcTemplate is great to simplify a lot of things, but it's not good if you have to handle a lot of joins because it will be on your side to build everything. And if you are returning just a few rows, maybe Hibernate it's a better approach because you don't have to provide the queries, you just have to explain what are the relations between the entities, and Hibernate will do everything for you. But of course, if you are doing queries that returns, for instance, thousands of rows, Hibernate it's not a good approach. Best approach probably. You need simplicity and performance, in this case, and maybe JdbcTemplate would be better. Okay, you have also MyBatis. I think it's a mapper. I never use it, or I used it a long time ago. I think it's a kind of a mapper where you have explicitly say this column should be mapped to this attribute, but I think you don't need it anymore somehow, unless you have some legacy application that you are handling. But using the BeanPropertyRowMapper and things like that can usually apply the same results. Of course, there are people that probably they will swear for MyBatis, but I think with the different technology that you have in Spring Boot, I don't see any reason to use it unless it's already in your application. And Spring Data JDBC, these are other technologies that are great. They can simplify a lot some of the queries that we are doing, but I will address this in the future. But okay, the fight here, it's more about Hibernate versus JdbcTemplate. From the popper point of view, I'm not creating this debate, but I already explained some difference, but I will provide you also the other technologies in future videos, and then at that time you can compare all of them. But every time, by the way, I introduce a new technology, I always compare with the previous one that I explained. So if you are following my videos, or if you start to follow later, you will see that I'm explaining the difference, and you can, if it's interesting to you, can return to my previous videos or wait for the next ones. I hope you see all of them, but of course it's too much information to handle. Okay. Summary: JDBC template offers power and simplicity. Yep, simplicity. It's the here, unless you are using complex join, then that is not simple. But okay, to be fair, it handles for you the prepare statement, the open and close, the result set, the connections, and so on. So anti-patterns must be avoided to ensure scalability. I think it's a universal rule. Avoid as much as you can anti-patterns unless you have a reason to not do so. Remember that every rule has an exception, and sometimes there are exceptions that we should take into consideration. And always structure result extraction based on query complexity. So thank you for watching these slides. I will now provide you some code walkthrough to see this working. So I've improved our application, our Spring Boot application. I already started the application, so we don't have to wait later for it. But what I did, I just created new tables here. I've had transactions and categories, so we can do a complex query with this join. If you are following my previous videos, you already know about these users, entities, and password reset tokens. All of them, they have a specific purpose, and they will have in the future some purpose. But now I'm adding categories and transactions since I'm, let's say, building a kind of financial system, quite simple, a personal money management with incomes, expense. Don't expect to be high professional, but it should be practical. And I think it's always a good example with some self-interest in it because it's about our money. So we have these transactions. Transactions, things that we do, like buying things, selling things like that, services. And categories is like groceries, utilities. Entities are the place where we do these things. Okay, of course, users, it will be the users that can access our system. I'm also providing some data. And if you see my previous video about H2 database, if you didn't, please go there because it's a database that can run in memory. Spring Boot handles this database quite well. And you put these two files and additional configuration in our application properties, and by out of the box you have a database running in memory, so I don't have to install any Postgres or MySQL on locally. And by the way, H2 database is compatible with those databases, at least in 80% of the features. Don't expect advanced things, but I think you'll be impressed if you don't know about the H2 database. And it's like this. H2, you can find information on the internet, and you can also find information. I have a set of videos explaining a lot of details about this small but very useful database. It's really popular if you develop unit testing or other integration testings on the Spring Boot. Okay, but let's return to our code. So I've created also a REST controller that you can find it here for the categories. Here that returns the categories and the transactions belonging to a category here, filter by category, and this will be our example for the join. Okay, I've created also the transactions REST controller that just return transactions, so we have a full implementation, minimal viable product. I'm not putting CRUD here. I'm not creating transactions because we didn't reach that point yet, but I also created in the past. If you go to the users, you can see that they have a lot of them if you want to explore the code to create users, treat users, and things like that. But since in this version I just had the transaction categories, I wanted at least to have a get all transactions and get all categories on the REST control, so we can do a call from Postman or other REST client. And of course, I created the service, common service. I'm using now the interface approach, something that I explained earlier in a previous video. So I'm putting the interface, and then we have implementations, and the implementations will be the Bean. So you can see that I'm implementing the interface, and this is the service. And usually what we do, if you don't remember or seeing this for the first time, we inject the interface, and Spring Boot will look automatically for beans that implement this interface. And this will be great because later I can replace, for instance, this service when I'm testing with a test one. And since it implements interface, I don't have to change the REST controller, which is quite nice. Okay, but we'll address that in the future because you can say, okay, what if I have multiple? Yeah, I provided a video about that. You can use qualifier, the primary annotation. You can disambiguate or teach Spring Boot to do what Spring Boot should do in those cases. Okay. Now, apart from the service, I also create, of course, the repository. Again, we have the category repository, again with an interface. And then we have the repository here. Okay, and of course I'm injecting JdbcTemplate here, and I create the query to return all the categories. You can see that it's quite simple. You just query, you provide, I'm doing an instance of the category, and I will just return it. I could have used the bean property approach. It will work because the name that you are seeing here, it's the same names as we have on the class. And if you go to the category, you can see I have here ID, name, and type. And for the transaction, which is here on the domain, you can see the attributes for the transaction. You can see I have the category ID here and not the category. Okay. Of course, when we start to talk about Hibernate, probably you will see here not only the category ID but also the object category, but that it's because that's the way to do it in Hibernate. In JdbcTemplate it's not necessary. Okay, and I've created also this category with transactions, and I'll explain in a moment why. So I have this category transactions which contains an instance of a category and the list of transactions belonging to this category. So let's return to our example. So I have here, I'm returning all the categories, and here I have the join, which is the subject of our video. And in this case, you can see I have this select, and I'm joining categories with transactions using of course category ID, and then I'm using the code that I presented on the slide. So we have a map. Here we will have the ID of the category, and here I'm expect an instance of this class, not a category, but a category with transactions. So which is this class. So the category with transactions. In the example, I show a customer with orders inside. I don't like to put the transactions inside the category because the transactions are not, it's not an attribute for the category. It just, it makes sense. It's a relation that exists on the database, on the business point of view, but every time I get a category, I'm not interested on the transaction. So why do should I put a field with a list of transactions every time in the category? So every time I will have to take care about initialization an empty list, and at some point people start to ask, but are the transactions here or not? What is the criteria to put the transactions here? And most of the time you don't need the transactions there. So I don't like to put it here. So there are two approaches that you can use. One is to create a class like this one, which is a container. And this class, the only thing that it does is it puts the category and transaction. So when I'm using this class, I'm indicating that I'm sure that I have transactions here. These are the transactions that belong to the category. Otherwise, I should only use the category. Another approach that I think it works well also is just to put this class extending the category, so you can remove this line and you have access to the category. So that's another way to do it. I prefer this one because it shows clearly this is just a pack or a container or a data transfer object that takes a category and this list of transactions and return to somewhere. It's just a transporter of information. Okay, but okay, it's the way you want to see it. That's my purpose. That's why I'm using here a map. This is the idea of the category, and this is the category with transactions. So I'm following the same. So I get category ID. I use the compute if awesome to check if it already exists on the map or not. If it doesn't, create it and add it. This is the code. It will be added to the map with this new category here, this return. Remember this code, it's inside this lambda here, this ID, and if it exists, it will be returned to me the category that already was created here on the map. And after that, I'm just taking the transaction information, and I'll just get the ID of the transaction here. I create the transaction, and then I will add to the category that I got here. Because I always get here a category, or it will be created and returned, or it already exists. And in that case, if it was already returned, when it creates an empty place for the transactions, and now I'm using that place to add. So when it exists, only transactions will be added. If it doesn't exist, it will be created, and then the transactions will be added row by row. That's a strategy I have explained previously. Okay, and then I return just the get, not the map, because I'm just returning one category because I'm filtering the method by one category. But you can apply also this example. If you remove this parameter, you just remove this where, and here you just return the values of this map. This map here. So at the end of the day, you can ask, okay, why use the map if I am only interested in one, just for educational purpose? So I want to make sure that fits the purpose of the video, but you don't need the map. But usually you want to use a map if you don't use this parameter. But if you remove this map, you don't need this compute if absent, because you you already know that you only have one category here. Okay, but of course we still need this code here, but you don't need all of this here. You just need to take care of these transactions and add them to the category that you already created. Okay, that's in case you are wondering, okay, why did he put a map if it's only one? Again, for educational purpose, you can take this code and create another method to return all the transactions for all categories or a range of categories. Maybe you want to, rather than have one ID, you have multiple ID here, have an array and do a select in here, so you support multiple and you don't have to change the code here. Okay, that's the purpose of this. So let's see this working. So I've created here some requests here, let's say categories and transactions. If you go to transactions here, I'm just doing again. This is a kind of a postman, but it's inside the IntelliJ. Even Visual Studio Code and other tools, they have this kind of a plugin, which is a REST client that you can use. And you can see here the list of transactions, okay, being returned. And for the category, in our case, we can see if I play this one, which is all the categories, you can see all of them here. They are 5. Okay, and this one, it's our one. So we have these categories, one transactions. If you want to see the details about it, where is the REST controller? You can see here I'm returning, just call the service with get all categories. And here you can see they have categories / ID, which is the parameter, which is the ID of the category. And I want the transactions of these categories. Filter by this one, so I get transactions from the service, the bins that I explained to you earlier. And then we'll call the repository and you'll return a category, just one instance, not a list of them. But remember, it's just a category with a list of transactions. That I didn't want to complicate and put a list here. It will be a lot of output just to show a simple join example. So let's return to our categories. So again, I'm using for the ID 1, category 1 transactions. Let's play this. Okay, it was quite fast. So you can see here the category as we saw in our, where is my class? So this is the domain class. This is the DTO, which is our category that we can see here. And then the transactions here, which is this list. And you can see here that the category, it's always this one, the number 1 that we ask for. Okay, as expected. So this is the way to implement JDBC template with complex joins. It's not easy. It doesn't make your life easier. Okay, it provides you already, again, out of the box, the prepare statement, the open and close connection. But the other thing, it should be handled by you manually. So this is where the limitations of the JDBC template start to appear, and that's where you start to wonder, maybe I should in some scenarios use different technologies like the Spring Data JDBC, or maybe Hibernate or other technologies that I will address in future videos. So I hope you liked this video. Thank you for watching. If you reach until here, please share, subscribe my channel, share with your friends, share in your channel, for instance. I think at least I'm trying to provide value on my videos, my experience in architect. I like to teach. I'm not receiving nothing for these videos. I really like to share information. I think I learn from it. It's not that I'm sharing, give it to the others. Every time we teach to someone, we learn more about it. And we learn not only about the subject, even communication, even other things. I think it's quite great to share what we know. And I think we are not losing when we share. I think we are always receiving ourselves something. Okay, so again, thank you for watching, and I hope to see you in my next video.